Welcome to the first demonstration of solar water pump implementation and power saving with 4 different time slots. So here we kept the time slots for 5 seconds, 10 seconds and 15 seconds and 20 seconds. In real time we can go with up to half an hour or 1 hour or 1.5 hours, like that. We can provide the timing programming inside the PIC microcontroller. So the main purpose of this timing is, if you want to control the motor for certain time, instead of keeping a person over there and check for the timing, and after that switch off manually, it be time taking process, it maybe leads to some faulty cases. So when we place a machine by programming that in embedded C language, it will take care of the timer, and whenever the time completes by selected by the user, then automatically it will switch off the particular motor commands, and that will be reached with help of electromagnetic relay. So here we are using 5-volt operated 7 amp load can be handled by this relay. So when we provide the timing input to the PIC microcontroller, so the system will display on the LCD, and it will keep on count down the timer. So whenever it reaches to 0, then it will switch off the power supply to the relay. So the relay will switch off the power supply to this motor. So here we are using DC water pump, as the whole system driven by this 9-volt solar panel, which is of 5 watts, and this voltage will be given to this battery. So here we are using 8-volt battery, which is rechargeable, and to this battery through this charging circuits we are providing. So here we have the 2-way of charging for this battery. Whenever the sunlight is available, we can charge this battery with the help of the solar panel. Whenever the sunlight is not available, so by using 230 volts input to this transformer, we can charge this battery. So let me show you the charging way through the 230 volts AC inputs. So when we provide the 230 volts AC inputs to this transformer, so transformer will step down the 230 volts AC to 12 volts AC, and there are the 4 diodes are connected in a manner of bridge rectifier. So we will get pulsating DC. That is going to be the 12 volts. So sorry, 11 volts, as the 4 diodes are connected in that. While working the bridge rectifier circuit, 2 diodes are connected in series with the output. So 1.4 volts will be dropped. So it will get around of 10.6 volts. So that is sufficient to charge our battery. And there are 2 diodes purpose is, if the battery is fully charged, then it will become the high potential one, and then diodes will stop the current flow from the battery to the transformer. So in order to protect the charging circuitry along with the transformer. And then next, if we connect the solar panel, means if you want to charge a battery using solar panel, so we need to place the solar panel under the sunlight and disconnect the T from this T or S slots and connect the S over there. So that we can see, due to this normal low lighting, we will get the light indication. So here these 4 diodes generally used for AC to DC converter, though we are providing DC power supply. So then these 4 diodes will act as a polarity corrector. So the purpose is, if we connect the solar panel in reverse direction, then if you don't place these 4 diodes, so directly minus plus minus will be connected to the battery, so that either battery or solar panel damage. So in order to protect that, we are going to making use of same bridge rectifier as a polarity corrector when we provide the DC inputs. When we provide the AC input, it will act as a bridge rectifier. When we provide the DC input, it will act as a polarity corrector, means alternating inputs given to the rectifier circuit, it will correct the polarity and provide the plus minus. So that same remaining is diodes purpose is same and directly given to the battery. And this is the main on-off switch. Once the battery is fully charged, we can utilize the system. So once we on this, the 8 volts will be given to this motherboard. So this is a PIC16F72 microcontroller motherboard, so which will take the 8 volts inputs and through this capacitor. So when we are on off the motor, there will be a chance of providing the back EMF due to the induction generated from this motor. So for that, utilizing the ripples, we are making use of 2 capacitors, before regulation, after regulation. So when we provide the 8 volts, so but the microcontroller need 5 volts. So for that purpose, to regulate that to the 5 volts, so we are using 7805 regulator. After that, 5 volts will be given to the microcontroller. It starts reading input from the control buttons. Based on the input selection, the timer starts on the LCD, and till that timer, the relay gets switched on. So on this motherboard, there are the 2 important components. So one is reset switch to restart the microcontroller. Another is crystal oscillator to provide the 20 mega clock pulses per second to the microcontroller. The purpose of the oscillating frequency is, so controller need 1 clock pulse per instruction to execute, so that we are providing 20 mega clock pulse. So means 20 megahertz means 20 mega clock pulse per second, so that controller can execute 20 mega instructions per second. And this is going to be the power status LED indication, and this is program LED status indication purpose. And the next, coming to the relay board, there are one transistor, one LED indication, one diode, two resistors. Two resistors purpose is current limiting purpose for the LED and transistor. And the microcontroller, to on the motor, it will switch on the transistor first, and then transistor switch on the relay. Relay switch on the this 9 volts power supply to the 8 volts power supply to the motor. So these are the switches flow, and LED will show the status of the relay. And the diode purpose is here also same. When we are on and off this relay, so it's electromagnetic relay, consists of induction coil inside that. So when it's getting on and off, it will provide the back EMF ripples, so that will be neutralized by this IN4007 diode. And the status of LCD continuously showing. So the pin connections are, these four switches are connected to A0, A1, A2, A3 pins, and relay connected at C0, pin number B2 to B7, LCD is connected. So let us see the demonstration. When you switch on the kit, there is a welcome message on the LCD screen, and then after LED on and off 2 times, so it will show that motor status is off and time is going to 0 seconds. So if you select the 5, so the motor got started, and LED indication and the same LED indication on the relay. After time completes, automatically off. So let us go to the 15 seconds. Same indications on the motherboard as well as to the relay. Right. Okay.